Good
afternoon. My name is Prince Johnson Collins Kagame. I work with Akila Institute, situated in the capital city of Rwanda, Kigali, in East Africa. I'm going to discuss with you the internal components of our computer system. But before that, let's talk about what houses these internal components. What houses these internal components is what we call the computer chassis, or the housing of a computer system. The housing, the size and shape of this computer chassis is what we refer to as the form factor. And this also determines the shape and size of the motherboard. With me here in front of me, I have this box, this computer chassis of a Dell computer. This one you can see, this is Dell. I'm going to open it so that you can see the inside as we go on with our discussion. Some of the computer chassis have screws that you have to screw off so that you remove the lid whenever you want to approach the inside. But for this computer chassis, we have a slider just here that you pull off so that the lid lifts up and then you remove it from there. So this is what I'm doing. Right. From there then, we'll go on to look at the inside of the computer chassis and see all the internal components of our computer system. First of all, this chassis is made in a way that it allows room for all the computer components inside it, and apart from this room for these components, we have enough space which allows the passage of air and saturation of air inside this environment, so that this cold air carves away all the heat that has been generated by the different components inside the computer case. Thereby, I'll begin to show you the different components. At some point, I will have to remove so that you see exactly what is inside. We have what we call the power supply. The power supply is the device that distributes power to the different parts of the computer components. This power supply here is a bit advanced because it is able to supply power to IDE components and both SATA components, SATA devices. I'll show you some of the components of this power supply. It has the main connector. This main connector, it has 24 pins. The main connector, it connects to the motherboard. It connects to the motherboard onto which most of the components we shall see here are connected. So the power supply supplies power to the motherboard, as you will see, and then to the different other parts of the components in this computer casing. Now, this power supply receives power of 240 volts here in Africa. And in some regions of the world, we have areas where the power input of many devices is just half of that, which is 110 volts, for example, in the US. So for you to be able to set exactly the input voltage of your device, your power supply, we have got what you call the voltage selector. The voltage selector, you can see it right here. Right here, you can either select to 230, or you can slide and then you select 200 and you select 110 volts. So you must be very careful whenever you are connecting your power supply. And again, what we have talked about the power supply is that whenever you're buying your power supply, you must consider the output, because what your internal components need for the proper running does not have to be equal to what is the output of your power supply. There must be at least an excess from the output of the power supply so that it supplies your components sufficiently, but also has but also is able to supply other components if needed. Because at one day you might need to add something else in your system. You might add another hard drive, you might add another CD-ROM drive. All of those will need extra power. So you need to buy a power supply that is going to be having more to be supplied to any extra component you might add in your computer system. The second device I'm going to talk about is the motherboard. The motherboard is the main printed circuit board of a computer system. This one connects all the components of the computer. All the parts of the computer are connected to the motherboard. The motherboard, as you can see, I will try to remove some of these cables here. This one you will see also. Now, on the motherboard, as I've said, every component, every device is connected. So here, you can see on the motherboard we have memory. These are memory cards. I can show you. Memory, this is RAM. On the motherboard, we'll find the processor. The processor is in here. We'll find PCI slots for expansion purposes. We have the CMOS battery, and you have these other storage devices all connected to the motherboard. Now I'll go on showing you one by one. The first that I want to talk about is the processor. The processor, in fact, is the brain of the computer. Without the processor, you cannot do anything. The processor does all the calculations of the computer. It does all the manipulation of the command that you enter into your computer. All the requests you give the computer are done by the processor. So the better the processor, the better services you get. Now, I'll use my screwdriver here to show you better about this processor. I will remove there. Now, the processor is a very small and tiny device, but very important, very crucial, because it does a very great job for us in computers. Now, this is our processor. As you can see, it is very small, it is very tiny, but very, 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 very important. So the processor, as I've told you, does all the calculation in the computer. Whenever the processor is doing its operations, it generates a lot of heat. It generates a lot of heat. And as it generates a lot of heat, it requires to be kept in a very good temperature. So for that case, we have what we call the cooling system. The cooling system is just there to help us remove the generated heat out of the processor or out of the environment of the processor. So we have what we call the heat sink. This metallic device that you see is called the heat sink. The heat sink, it sits directly on the processor. And when the processor is working, the generated heat is absorbed by the heat sink. This heat sink is made in such a way that it has fins. These fins have very big, space. They have big surfaces which help to dissipate off the generated heat. And inside here also, you will see inside here we have in our cooling system of the processor a fan, a very strong fan, a big fan. This fan is used as it runs around and it continue rotating and running. It sends cold air which passes through the fins of the heat sink and running away or dissipating off the heat that has been generated by the processor through the heat sink. And this rod here, this rod you see here, it helps to collect together the air that has been pushed along by the fan so that it runs right away with the heat generated. Maybe I can put this aside here so that you can see other components. Now, besides the processor, there are other two components that I would like to show you. That is, these are two chips here, two sister chips here. One of them we call the North Bridge and then the South Bridge chip. The North Bridge chip on the motherboard helps to communicate with the processor and the high-speed devices. For example, RAM, that is memory, and then we also have the VGA or the PCI, that is PCI Express, where we have the VGA, which also requires high-speed running. Also, this North Bridge communicates, links the South Bridge to the processor. Now, the South Bridge is a chip that does communication, that links the processor through the North Bridge and the low-speed devices. Low-speed devices, for example, input and output devices. Now, I'm going to talk about memory. Memory, here we talk about on the motherboard, is storage. Storage also. Storage, we have temporary storage and you have permanent storage. With permanent storage in memory, we refer to ROM, read-only memory. And in fact, with RAM, we are referring to temporary storage of data. We also have the CMOS battery. The CMOS battery is a physical device that is connected to the motherboard. What it does, it facilitates the standard or the updated information in ROM. For example, that is in the BIOS, where we set time and date, where we have other settings and configurations of the way the computer want it to run. We want the computer to run in such a way that it has the devices to boot. We want it to boot first from the hard drive, from the memory stick, from the CD-ROM drive, depending. All this information is kept in the BIOS settings. So the BIOS is facilitated by the CMOS battery. And other devices that we can talk about inside here is the CD-ROM drive. The CD-ROM drive is here. You can see. Let me bring close out my camera. The CD-ROM drive. This one will help us to read data on DVDs and CDs. It will help us to write. Actually, it is a DVD writer. Then we have diskette drive. Diskette drive. This diskette drive, today we no longer have many of them. This floppy diskette drive. We no longer have many of them, but actually it is here. It is good for those who have them. You can still use to store as data. It still works anyway. Now, we also have our hard drive. Hard drive. Our hard drive, let me remove it. It will be easier for me to remove. Our hard drive. Our hard drive is the main storage component of our computer. It will store all the data, all the programs, all the softwares, everything will be stored in here. That is the hard drive. All of these components, the drives as I have shown to you, are supplied with power that is coming from the power supply. They connect to the power supply will be connected. Power will be connected to the CD-ROM drive. It will be connected to the hard drive. It connects the motherboard. It will connect the CPU. The CPU will also be supplied with power, and this power is connected to the motherboard, so the motherboard will distribute to the CPU. And now, apart from the power, these devices, as I said, they are connected to the motherboard through different channels. We're having these cables, you can see. They are called bus cables. They run from connectors on the motherboard to the different devices that they are intended to connect. Also here, we have PCI slots. These PCI slots are used to extend services, to extend the functionality of the motherboard. We can connect in here network cards, we can connect audio cards, we can connect anything else, USB cards, today PCI cards, you can connect them, and then you have the functionality of the motherboard extended. Now in here I have a card. It is a VGA card. As you can see, this VGA card also has its heat sink. It means it generates heat also when it is working. That is why you have a heat sink that is connected, so that it can dissipate off heat that has been generated by this video card. I believe when maybe we look at the behind, the rear of our computer case, we can see this port here. This is the VGA port, which is having 3 lines, each of 5 pins. But of course, this is a female one because it doesn't have pins. These are 15. Then we have the audio section, where we have the input, output of the audio. Then also we have the USB ports. This one here, you can see is just the network card integrated on the motherboard, which is the RJ45, as you can identify. I believe we have tried to look at almost most of the internal components of our computer system. Now, what I'm going to talk to you about finally is what we call buses. Now, what are buses? I would like to do this by a small demonstration on my whiteboard as you follow. What are buses? Buses are communication channels that transfer onto which data is transferred between one device and another. Buses, they are lines that run across the motherboard from the one place to another, from one component to another. Buses, when you talk about the system buses, system bus, when you talk about the system bus, we refer to the channel, the communication lines that run from one component to another. And these ones are divided into three separate functioning groups. The three functioning groups are the data bus, then we have the address bus, and then we have the control bus. Now, these lines are running between three main components. The three main components are the CPU, memory, and then the input output devices. Now, the data bus, I would like to demonstrate it this way and briefly. Let's have our CPU here, and then our memory, and then our input output unit. Now what happens is this. As I told you that these are lines, all wires, all communication channels. When you talk about the data bus, it is a set of lines that run between the CPU, the processor, the CPU, the memory, and the input-output unit. That's the same applies to the address bus. The same applies to the control bus. Now, let's assume this is the data bus. And this is the address bus. And this is the control bus. Now, inside here, inside our computer system, there are many activities that are taking place, and these activities have to be controlled. So, the computer would like, when our system, when our processor, our CPU wants to read a certain piece of data from the memory, it will request, we say this is the data bus, address bus, control. Now, the movement of data from the CPU to the data bus is bidirectional, because data can be requested by the CPU and then the CPU can send data to be written to memory or to the input-output device, and it can also come from either the memory or input-output device to the CPU. That is why it is bidirectional. And from the CPU to the address bus, we have a monodirectional movement. The CPU will make a request of data from the memory and the input-output unit by pressing an address, by requesting the address bus. So the address bus will send signals to memory and also to the input-output unit. Data, as I said, will move the same here and the same bidirectional from there to the CPU and from the CPU back. Now, we also have another movement, another bus, which is called the control bus. The control bus does the control of the activities that are taking place between the data bus and the address bus. It has to know the time at which the data has to be placed on the data bus from the memory or input-output unit, and it also has to be when it has to go off. It has to know to control the addresses. It has to know all the information. The control bus also has to know all the information about the status of the devices from which we are going to get from the input-output devices or memory as has been requested by the CPU. So this one is also a bidirectional movement. Briefly, as I told you, the CPU, when it requests data from the memory, it sends a signal to the address bus. The address bus will go and look for the memory location, the data location in memory or in the input-output device. Then this data from the input-output device will be pressed to memory, and then this will be also placed on the data bus. So the main function of the data bus is to carry data from CPU and along these two other components and back. And the address bus, the main function is to know the locations of the memory. Please, sorry, I've been distracted by my camera, but actually I would like to wind up. I would like to summarize all about the system bus. As I have said, we have the system bus, which we have defined as communication channel, a link of communication, transfer of data between one component and another component. We have said that the main components which connect, which the system bus connect are three. These are the CPU, memory, and the input-output devices. Those are the three main components which are linked by the system bus. And again, in the system bus, I have said, there are three different functioning groups, which are the data bus, the address bus, and the control bus. So, I would like to thank you very much for your kind attention. Thank you very much.